forget the billion-dollar stealth fighters you're used to seeing. In 2026, the real future of the U.S. military fits in the back of a pickup truck, and it's driven by AI. The Pentagon has officially flipped the script. The era of buying a few expensive, exquisite platforms is over. Today, we are entering the age of affordable mass. Here is how the U.S. is completely rewriting the rules of aerial warfare this year. Let's start with the heavy hitters, Collaborative Combat Aircraft, or CCAs. These aren't your average remote-controlled drones. They are AI-piloted loyal wingmen powered by jet engines. Right now, two major prototypes, the YFQ-42A and YFQ-44A, are in active flight testing. The goal? To fly these robotic wingmen alongside human-piloted F-35s and future fighters. They can fly ahead to draw enemy fire, jam radar, or launch their own missiles. Best of all, they use open system software, meaning the Air Force can swap out AI brains from different vendors in a matter of hours. But what if you need sheer numbers? Enter the Replicator initiative and the Army's brand new Sky Foundry program. The goal here is staggering. By the end of this year, the Army aims to mass-produce 10,000 small drones a month. The plan is to put cheap, attritable, meaning expendable, attack drones in the hands of every single squad. In a near-peer conflict, these swarms would overwhelm enemy defenses through sheer volume. And because the enemy has drones too, the Pentagon is fighting fire with fire. Under Replicator 2, we are seeing rapid purchases of AI-driven interceptors, like the Drone Hunter F700, which catches rogue drones in mid-air with a net, and the low-cost Bumblebee V2, designed to physically crash into incoming threats to protect U.S. bases. 2026 is the tipping point. The U.S. military is trading million-dollar risks for $1,000 swarms, prioritizing AI and speed over legacy hardware. The face of warfare has changed permanently. But the aerial revolution we just talked about? That's only half the story. If you want to see where the real science fiction is happening in 2026, you have to look at how these drones are being deployed, commanded, and supplied. Let's look at the ocean. The Navy isn't just sailing multi-billion-dollar aircraft carriers anymore. They are deploying ghost fleets. We are now seeing uncrewed, autonomous ships acting as mobile launch pads. A ship with 0 humans on board can sail into contested waters, loiter for weeks, and suddenly launch a swarm of hundreds of explosive aerial drones at a moment's notice. The lines between naval warfare and aerial warfare have been completely erased. Then there's the invisible web making all of this possible, JADC2, or Joint All-Domain Command and Control. Think of JADC2 as the military's ultimate AI nervous system. You can't have a human pilot manually flying 10,000 drones with a joystick. It's impossible. Instead, JADC2 uses artificial intelligence to process data from satellites, radar, and ground troops in milliseconds. It automatically assigns targets to the drone swarms, manages their flight paths, and ensures they don't crash into each other. The human commander simply issues the broader objective, and the AI swarm figures out the exact tactics to get it done. The human is no longer in the loop flying the drone. They're on the loop, supervising the AI. Finally, we have the heavy lifters. Combat is useless without logistics, and the U.S. Marines and Army are now using heavy payload eVTOL drones to move the blood, bullets, and batteries. Autonomous cargo drones fly just above the tree lines, silently delivering critical supplies to frontline troops without risking a single helicopter pilot. When you combine AI wingmen, disposable attack swarms, uncrewed launch ships, and an autonomous supply chain, you don't just get a new weapon, you get an entirely new way of fighting. The drones are here, they are talking to each other, and they are changing everything.
Typically, when you're flying an airplane, you're deflecting control surfaces in order to maneuver or to reject wind gusts. These deflecting surfaces all right, make the airplane more vulnerable to being detected by hostile forces. As we look to try to field next generation UAVs, we find that they're limited by the fact that they're more expensive than we'd like them to be. So to try to slash the weight and cost out of the system, we want to reduce their mechanical complexity. And to do so, we're looking at modern flow control techniques, which permit you potentially to be able to control the airplane in flight without the use of any kinds of mechanical surfaces.
throttle. So. Yep. Alright, take our road. Gyro's good. Pretty good. Alright. Over the way to the front. We're gonna check camera. Over the way. fly. It's one of the pre-flight checks. Well, no, I mean like the, we always call it the spur. And it has the additional. We got, it says 4+ satellites, but it could be 4 or it could be 5. You never know. Hey, do me a favor, go back to the sandbags. You're on that side.
We are at the doorstep of the future. We are experimenting now with certain unmanned systems, and experimentation is a first step before we can integrate those capabilities into, for instance, a maritime task group. So I think we are at the beginning of a long journey where we will see the unmanned systems mixing with traditional assets into perhaps even an unmanned future.
USarmy Pacific, an unmanned aerial vehicle manufacturing company, Platform Aerospace, conducted UAV flight and operations testing at Andersen Air Base, Guam during Exercise Valiant Shield 24. The UAV, known as Vanilla Unmanned, is a prototype aircraft designed to meet cost-effective long-endurance demand and provide the U.S. military with airborne intelligence, surveillance, and reconnaissance capabilities. Reporting from Valiant Shield, Guam, I'm Petty Officer Mike Flesh.
We start to see this alignment between the industry, what they are producing, and what NATO needs. And that's the reason we need to grab them to work together with us in order to align what are our intentions, and also to see what are their developments, and to have these alignments, to have a better products, not only for on the military perspective, but also for the civilian perspective. That's the reason we have RepMuse. RepMuse is also to develop civil systems and technologies.
So the only problem is it's the real. They have somebody out here doing surf, like actually training events and stuff like that. Yeah. Because they
It's clear that in the future, unmanned systems are going to be a very important part of the alliance's capabilities. It's truly impressive to see the different technologies that the nations bring and how they send their finest, brightest, and most motivated people as we work towards the future of unmanned systems.
In recent decades, military forces have had to come to terms with asymmetrical warfare, small groups of enemy fighters, such as snipers that use populated areas to attack U.S. soldiers. To combat this, the U.S. military, through the Small Business Innovation Research Program, developed an armed drone called Switchblade and changed the nature of warfare.
Our engineers developed what we believe is the first hand-launched reconnaissance drone back in the mid-1980s. That was Pointer. But it was really right after 9/11 when the first Special Forces teams went into Afghanistan. They found our Pointer system to be so helpful that resulted in massive adoption of subsequent products that we developed.
A smaller version of the Pointer, called the RQ-11 Raven, was introduced in 2003 for rapid deployment surveillance.
And they would use that if you're taking fire. That's a way to get a camera up and actually identify where they're at specifically, to find out who's doing it, what are they using, and if they're going to move, where are they moving to.
That was the catalyst for widespread adoption of Raven throughout the Army and Special Forces. That was followed in 2006 by our small and really hand-launched, wrist-launched, a WASP unmanned aircraft system for the Air Force, and then 2008 for the Puma system for the Special Operations Command.
These man-portable UAVs showed the warfighter under fire where the enemy was, but lacked the capability to engage them.
Especially when it's in a non-line of sight. So it's behind a building, it's over a hill, it's hidden, but it's creating damage and hurt on your team. To then, if you can see it, why can't we go ahead and take that out?
So the Air Force Special Operations Command awarded AeroVironment a small business innovation research contract to make a weaponized UAV called Switchblade, a bomber that could fit in a backpack.
It's about 5 pounds and it's 2 feet long and I guess about 3.5 inches, in the tube. So you can put a couple in your backpack.
So we consider Switchblade to be a tactical missile system. It really isn't a reconnaissance drone. It's basically a highly accurate precision missile that provides real-time video back to the operator so they can view the situation in real time all the way through to the end result.
Switchblade can be set up and launched in 2 minutes. It has a range of 10 kilometers and an operational time of 10 to 15 minutes. An operator controls the flight path with a tablet.
While they're watching that video, they're controlling it. That gives them positive control to ensure that the target they're addressing is the target they intend to address, and it also gives them the ability to wave it off if innocent bystanders happen to walk into the frame.
And the feedback from the soldiers on the front line has been overwhelmingly positive.
So to have precision fires and really your own kind of close air support in your backpack is just unprecedented.
Switchblade in its various configurations was adopted by units across the Department of Defense.
In the U.S. Department of Defense procurement budget for government fiscal year 2019, there was about $110 million in funding for the procurement of Switchblade systems for the Army's LMAMS program, Lethal Miniature Aerial Missile Systems program.
The Switchblade systems now account for about 1/4 of AeroVironment sales. That success rests on the role played by the Small Business Innovation Research Program.
The SBIR program was extremely important to us in advancing the Switchblade capability from a concept to something that we could actually demonstrate the value to our customers with.
So between Air Force Research Lab, our partners at Army, AMRDAC, and folks in the Office of the Secretary of Defense that also provided funding for that, provide expertise to assess our ability to scale and make it a successful product.
The FTUAS rodeo is the culmination of a year-long soldier touch point we had within FORSCOM. So about 2 years ago, we started the effort to procure some industry-available, non-developmental Group 3 UAS to provide the latest capability to soldiers to evaluate over a 6-month period.
The VTOL system allows us to take off from anywhere that has between 100 and 300 square feet of space, even if it's in an urban environment. It's much less ground equipment. From truck to air is about 2 hours.
You don't really need a runway. You're not going off of a launcher. You can pretty much put it anywhere.
It was a lot simpler. There's definitely a lot less equipment. It's easier to work on.
It's much quieter. The engine is way quieter.
Fewer moving parts, so there's less to fail.
We can be driving and controlling the aircraft at the same time, so we can stop at any location.
Take 8 personnel on another Blackhawk and fly it out and land in a clearing and set the aircraft up and fly from that clearing.
From setup to flight, we can get a flight up in about an hour.
I'm excited that we're listening to the soldiers that operate the system to tell us what we need in order to get it right for how they want to use the system and the intelligence, surveillance, and reconnaissance requirements for the brigade commanders and below.
This week we're trying to set an endurance record for the aircraft. You can hear the wind in the background. That's making it a little bit challenging, but we're plugging away at it. Hybrid Tiger is a Group 2 long endurance UAS, so that essentially means it's a 55-pound flight vehicle. Most Group 2 UAS systems are limited to about 8 hours of flight time, generally more between 2 and 4 hours on conventional fuels or fully electric aircraft. With a system like Hybrid Tiger, you can fly much further than that. And since we've switched to hydrogen and are using solar energy in combination with hydrogen, we can get much, much longer flight times.
And so you see that there's a huge improvement in using the technologies that we've employed in Hybrid Tiger. Hybrid Tiger is unique in a few different ways. It pulls together several different energy technologies that have been under development at NRL for many years. So the real prominent ones are hydrogen fuel cell propulsion for unmanned aircraft, composites integrated photovoltaic arrays, so solar arrays for energy harvesting, auto soaring, so using rising air currents in the atmosphere to harvest energy from the atmosphere, and then also energy optimal planning, plotting a trajectory for the aircraft from where it is to where you'd like it to be that consumes the least fuel, based on your knowledge of the forecasted weather and the local environment. So we pull these technologies together in Hybrid Tiger, which is where the name comes from, and together they enable Hybrid Tiger to fly for multiple days.
The ability for us to put assets out there and keep them out there for 4 or 5 days, this really allows us to kind of take a new approach to maritime security, and frankly to maritime ISR and our ability to look at named areas of interest and targeted areas of interest.